All right, so this morning I'm going to go into complex numbers and also known as imaginary numbers. All right, so complex numbers, also known as imaginary numbers. To get a conceptual idea of what an imaginary number is, we first have to understand what a real number line is. All right, so there are many definitions you may be able to find if you Google it, if you look through different textbooks. I'm gonna give you the most common sense answer to what a real number line is. A real number line is basically any point on this line. If you can find a location here, you have found a real number. So that would include positive numbers, negative numbers, whole numbers, fractions, decimals, irrational numbers, something like a square root 2 or a pi or e, anything. If you can find its location anywhere along this line, you're looking at what we call a real number. So I'm going to start off with this statement. If x to the second power is equal to 4, then x equals. And then at that point, we have to figure out, okay, what number can we raise to the second power to get 4? All right, so x is equal to 2. If you have x is equal to 2, remember, you're halfway correct. And here's my proof. So if I say because, and then all I have to do is basically put my number in there, right? I could put a 2 in there, and that would be true. 2 to the second power is equal to 4. But we cannot forget, if I put a negative 2 in there, my answer is also 4. All right. So we're going to start with that, and then I'm going to connect that into why we have imaginary numbers. So here's my challenge to you. Think of any number. I don't care what number it is, and you could try it out with your calculator numerous times. Pick a number, raise it to the second power, and I guarantee you that that number will be a positive number. All right? Take any number, raise it to the second power, and you're going to get a positive result. Test that out with a lot of different numbers on your real number line. All right, so we have 2 times 2 is equal to 4, and that's a positive 4. We have a negative 2 times a negative 2 is equal to a positive 4. This is how real numbers behave. No matter what the real number is, you can pick any number off of the real number line, and if you multiply any number times itself, you're going to get a positive result. See, a positive times a positive is a positive. A negative times a negative is a positive. But how can we get a negative times a negative to equal a negative? To do that, we have to leave the real number system and go into what we call a complex number system, also known as imaginaries. All right, so here's the foundation for complex numbers, also known as imaginary numbers. That stands for the imaginary unit. So the imaginary unit is equal to the square root of a negative 1. The square root of a negative 1. Now, if you try to take a square root of a negative 1 in most calculators, it's going to say there's an error. It won't even allow you to move forward. But in mathematics, we go ahead and give it a definition so that we can begin to use this mathematically. So before I move forward with the rest of this imaginary, I want you to kind of see if you notice any type of pattern. So right here I have the square root of 2 times the square root of 2 is the square root of 4. But the square root of 4 is equal to 2. Okay, I have the square root of 3 times the square root of 3. There we go. It's equal to the square root of 9, but the square root of 9 is 3. Square root of 4 times square root of 4 is square root 16. But the square root of 16 is 4. Do you notice a pattern? I would literally keep writing these down until at least half of my students pick up on what's going on. If they pick up on what's going on, then it forces me not to have to teach it. They have to understand it at that point. So what it does is this provides us with some type of shortcut. What I notice is if I have a square root times itself, I could skip over this middle part and just jump straight to the end. Get what I'm saying? So when I see a square root of 2 times the square root of 2, I just jump over and say, okay, the answer is 2. And that's how it works with any number in the real number system. So if I have a square root of something times the square root of something, it's going to be equal to whatever that number was under the square root. That's how that rule works. Now, what we're going to do is, now that we created a definition for imaginary, we can use what we know here to extend that idea. All right, so using that shortcut that we borrow from the real number system, what I have is a square root of -1 times the square root of -1. That will skip me or jump me straight to -1 over here at the end. Now, remember, we're borrowing that idea from a real number system, and we're applying it under a complex number system umbrella so that we can get past certain numbers when we run by them. It allows us to continue on in a whole nother arena, even though under a real number system, you technically don't even have an answer. So remember, the square root of -1 is what we assign the I variable. So what I'm looking at is an I times an I is equal to -1. All right. And I times the I is I to the second power. So this is the key point right here. I to the second power is equal to -1. Major key. All right. This is where our complex system is kind of rooted in this right here. Understanding that if I raise this to the second power, this is going to be the only type of number or only type of system that allows me to do a number times itself and still get a negative result. So if I ask you to evaluate what is the square root of 4, the answer is simple. The answer is 2. All right. The square root of 4 is 2. Any questions so far? Square root of 4 is 2. Now over here, I'm asking you what's the square root of a -4. But remember, because we have something going on here that's a little odd, remember, if you plug this into most calculators, it's going to give you an error. So what we do is we like to separate what we can calculate and then what we have to apply our imaginary to. So this one gives me a 2, but this one is also called I. So the square root of a -4 is 2I. See the difference? Square root of 4, real number, you get a 2. Square root of -4, imaginary or complex number, you get a 2I. That is literally the only difference right there. You take the square root as if this is not there and then put an I on the end. That's all you do. So in summary, I to the second power is equal to -1. And the reason why we can say that is because of this definition that we started with. So the imaginary is equivalent to the square root of -1. And because of this definition, that's why we can raise to the second power and get a negative number. All right. So this is where it is all founded in right here. This is where it begins. Imaginary units, complex numbers. All right, if you head to YouTube and do a search, you can type in BJ Jeffries right there. That's the correct spelling. It'll bring up your list, something like this one. Find this picture. You can subscribe to this channel. This is how you can find me. I put up my videos each day I come to work.